Hello, and welcome to yet another exciting and intriguing episode of Logarithm John's homespun math videos. Today we'll be discussing complex numbers and operations on these, including, but not limited to, addition, subtraction, multiplication, and division. Before we get to this, however, let's review the number I, the square root of -1. So I is an imaginary number. We know that for any real number, x squared is greater than or equal to 0. Right? For any real number. Meaning any number that could be represented on the standard number line, including negative numbers and 0. But if I is the square root of -1, this means I squared is -1, which is less than 0. So we know that I is not one of our real numbers that we're used to. It's not equal to the square root of 2. It's not equal to pi, or negative pi, or negative √3/5. It's a totally brand new number that we use our imaginations to think about. Now, a complex number is a number with both a real part and an imaginary part, possibly. So, definition. A complex number is one of the form a plus bi, where a and b are real numbers and I is this imaginary square root of -1. So anything that you can write in the form of a real number plus a real number times I is a complex number. For example, let's say 2 minus 3i, 3 plus 5i, even things involving square roots, because those are real numbers, so square root of 2 plus well, let's write it √3i first, but we usually write this as I√3, just as a matter of avoiding confusion, so we don't think the I is under the square root. Right, so all of these are of this form a plus bi. For example, here a is 2, b is -3, a is 3, b is 5, a is √2, b is √3, etc. Other examples of complex numbers could be even something like pi minus pi. So here, a is pi and b is -pi. Even all the real numbers themselves are complex numbers. Right, so if I just have a standard real number like 2.5, well, that's the same as 2.5 plus 0i. So, since it can be written in this form, this is also a complex number. Therefore, the complex numbers include all the real numbers that we know and love. And even something that's purely imaginary, so like -3i, but we can write that as 0 minus 3i. So that's also a complex number. Make sense? All right, first operation of the day, addition. Good news, folks. There's nothing easier than addition of complex numbers. All you gotta do is combine like terms. I think even you can do that. For example, let's say you have 2 plus 3i plus negative 4 minus I. Well, then we have some like terms. 2 and negative 4 are like terms, and 3i and minus I are also like terms. So we just combine them. So this sum equals, well, 2 minus 4 is negative 2. And if we have 3 i's and we take away 1 I, we're left with 2 i's. Ta-da! Let's do another example. Just as easy though. Let's say we had 16 minus 2i plus negative 7 plus 4i. Again, like terms. Oh, 16 and negative 7, those are like terms. And 16 minus 7 simplifies to positive 9. Negative 2 and 4i, those are also like terms. And they add up to 2i. That's it. Now suppose I have a complex number and I have a real number out in front that I want to multiply by. How do I do that? Well, here's an example. Say I have 2 minus 3i and I want to multiply this by 4 out front. All we do is distribute. So 4 times 2 is 8. 4 times negative 3 is negative 12. So the final answer is 8 minus 12i. Got it? Let's do another example. Let's say that we had, I don't know, negative 3 times negative 7 minus 2i. So distribute. Negative 3 times negative 7 is positive 21. Negative 3 times negative 2i is positive 6i. So the answer is positive 21 plus positive 6i. A special case of this is if we have a negative of a complex number. So let's say I have negative quantity 1 minus 2i. Well, this negative out front really represents negative 1. So we can distribute this over the expression. Negative 1 times positive 1 is negative 1. And negative 1 times negative 2i is positive 2i. So here the answer is negative 1 plus 2i. This idea will help us with subtraction of complex numbers. Okay, so let's say we want to subtract two complex numbers. For example, 2 plus 5i minus the quantity 4 minus 3i. Well, as before, we just treat this minus as a negative 1. We distribute, and then we combine like terms. So we have 2 plus 5i. Negative 1 times positive 4 is negative 4. And a negative times a negative is a positive 3i. Now the 2 and the negative 4 are like terms, so we get negative 2. And the 5i and the 3i are like terms. So our final answer is negative 2 plus 8i. Makes sense? All right, let's do another one just for practice. 3 minus I minus the quantity negative 2 plus 5i. Well, we make this a negative 1 and we distribute. So we get 3 minus I. Negative 1 times negative 2 is positive 2. Negative times positive 5i is negative 5i. So like terms 3 and 2, that makes 5. And negative I minus 5i is negative 6i. So our final answer here is positive 5 minus 6i. Easy peasy. Okay, what about multiplication of complex numbers? Good news about that. That's easy too. Multiplication of complex numbers is just foiling. Remember FOIL? First, outer, inner, last. Let's do it. So let's suppose we have negative 2 plus 3i times negative 1 plus 4i. Negative 2 times negative 1 is positive 2. Those are the first terms. The outer terms are negative 2 times 4i. Negative 2 times 4i. Haha, 4i's is negative 8i. The inner terms are 3i and negative 1. 3i times negative 1 is negative 3i. And the last terms are positive 3i and positive 4i, which makes 12i squared. Okay, next, let's just combine like terms. So the outer and the inner, as usual, those are like terms. So this becomes negative 11i. And we have our 2, and we have our 12i squared. Wait, but this isn't in the form a plus bi. What's going on? So secretly, the first and the last terms are also like terms. So don't forget, I squared is negative 1. So 12i squared is 12 times negative 1, which is negative 12. So this whole thing simplifies because we can combine the 2 and the negative 12, make negative 10, and then we have our negative 11i. Let's do another example for more practice. Negative 3 plus I times the quantity 7 plus 5i. As usual, FOIL. First, outer, inner, last. So negative 3 plus 7, or times 7 rather, are the first terms, and that's negative 21. Outer, negative 3 times 5i, that's negative 15i. The inner terms are I times 7, that's 7i. And the last terms are I times 5i, which is 5i squared. All right, combine like terms as usual. Negative 15i plus 7i, that's negative 8i. So we have negative 21 minus 8i plus, whoops, that's 5i squared, not just 5i, plus 5i squared. Are we done? Nope. Remember, the first and the last terms are also secretly like terms because I squared is negative 1. So 5i squared is negative 5. So now we can combine this term with this term to make negative 26 minus 8i. And we're done. Got it?